Episode 105, Top 10 Weirdest Things We've Found in Space. Hi, I'm Daniel, your host, and you're listening to the Visionary Variety Podcast. This week, I'll be talking with my friend Andy Cala, who went to school for astronomy. We're going to be talking about weird, cool, and oftentimes terrifying things we found out in space. All right, well, let's get to it. Welcome to the Visionary Variety Podcast, where we cover cool stuff like photo, video, film, books, and technology. So switch on your brain and enjoy the show. All right, so Andy, welcome to the podcast. I'm super excited to have you on here. Why don't you tell us a little bit about yourself? Where are you? What do you do? And, how'd you get into this whole space astronomy stuff?
Well, my name's Andy. I live in Indianapolis, and I got into astronomy for when I was young. I wanted to be an astronaut, and I failed at doing anything with engineering, and I wasn't really interested in the Air Force. So when I went into college, I was like, okay, maybe astronomy is, where I'll go. And then I took an insanely difficult first freshman astronomy class, and decided I wasn't smart enough for it. But I put in all the effort of making it through that one class that I wanted at least a minor for it. So I earned my astronomy minor, which is not on my diploma because apparently they don't list your minors on your diploma. So that was a little frustrating. So. Right now, I am working as an office drone for a heating and air conditioning company. I also try and do a lot of writing in my spare time. Kind of gotten away from that a little bit with having a toddler, but I'm hoping to get back to that. But I like to write science fiction as well as horror. Big fan of H.P. Lovecraft, which is where you combine kind of space and horror and science fiction all in one.
It's a cool mashup.
Yeah.
That's great. So where can our listeners find you online? Is there any place you put your writings or anything like that?
Yeah, I have a website. It's dannycove.com, DANNYCOVE.com. Danny Cove is my pen name that I use. So I've have a couple of books I've written there, and just a whole bunch of short stories. So the short stories are all free. So
yay. Man, I need to sit down and start writing some short stories. I've got some ideas that are just baking in my brain, and I want to write them. Try writing. You and I did a fun book project a while back where we did a test chapter, and that was literally the first type of fiction I've ever written in my life.
Really?
And I was pretty happy how it came out. And then we started working on the book, and it was really fun. I really enjoyed it. I never did that before, so I was like, "This is like so exciting." I'm nervous, but it's fun,
Oh yeah, I was so excited for that. I had all my ideas and everything, and then I had my chapter ready, and we just didn't get that far.
So we got to revive that thing.
I was like, well, I have all the ideas still in my head. Maybe I'll recycle them for other books and stories.
Right. Yeah, one of these days it'd be awesome to finish that. All right, so I have a huge passion for space as an ultra sci-fi nerd. You can't get away from anomalies and phenomena and strange scientific weirdness out in space if you are watching or listening or reading sci-fi. It's just what a lot of stories are based around. I mean, there's movies based around all the things we're going to mention today. I bet we could find a number of movies that circulate around each of our lists. So Andy and I have compiled a list of 5 things that we personally think are quite weird or interesting or cool. Something that we've observed or learned about out in space. It could be something vague, could be something specific. And we're going to try and not get too technical to where you can't follow if you're not, a science, if you don't have a science background in astrophysics or anything like that. So don't worry. If you're just a quote unquote normal person, you should be able to get something out of this episode, and we hope that you enjoy it. So let's get started. I'm going to start with my number 5. I'm going to work my way up just to, build anticipation. So my number 5 is a diamond planet that was discovered sometime around 2008. And I got a list. I just said I won't get technical, but I got a list of the scientific name for the planet. It's PSR J1719-1438. Isn't that a beautiful name for a planet?
Oh, yeah. Just rolls right off the tongue.
It does. Yeah. We're gonna have to fix that. In the future in sci-fi movies, they have such cool names for planets. How do they agree on those names?
I remember, what was it? The movie where the Earth was destroyed. It was animated, and they were trying to find the ship that could make a planet.
Oh,
AE
Titan
After
AE.
Earth, Titan AE,
Love that movie.
and he names the planet. He remakes the Earth, and he renames the planet Bob.
Yes.
So in the end, you see the cameras panning out, and it says, Earth 2, aka Planet Bob.
That's awesome. I remember that. That is an underrated sci-fi movie. So good. Scientists believe this planet is made out of pure diamond. That's because of the spectrometer readings show mostly carbon. And the mass of this planet is so massive. It's somewhere above the mass of Jupiter, but the size is much smaller. So this is a very dense and solid planet of carbon. And you'll see online, most scientists will, kind of generally classify as, hey, maybe it's solid diamond, maybe it's raining diamonds, maybe there's volcanoes and rivers of diamond. Who knows? Maybe one day we'll get there. But it's a pretty interesting phenomena, and it doesn't stop there. So the measurements of this object show that it had something rotating around it. And as they looked deeper, they found that there was actually a pulsar. So this is a binary system here. We've got a pulsar in the middle and this diamond planet rotating around it. But wait, it gets even weirder. So the scientists actually believe that the diamond planet once was its own small star rotating around the pulsar in the middle. All right, so we got two stars. It's called a binary system, and the outer star was smaller. The central star went supernova, kaboom, exploded, sent a bunch of energy and mass and all kinds of stuff outwards, probably destroyed the planets around it, except for that one star that was rotating around it, stuck around, and it actually destroyed part of that rotating star. The rest that was left of that rotating star was the core, and it collapsed in and became a super dense object, basically forming a planet out of what was a star. That's pretty cool.
So the planet and the pulsar were both the stars, and you're saying the pulsar went supernova and then blew off most of the other star, leaving only the core, which collapsed and diamondized.
Yeah, pretty cool, huh? Never heard of that before. That's what surprised me. This is like science fiction right here, but apparently it's mostly fact. I mean, from what we can observe and speculate, umpteen light years away.
Yeah.
Which just still blows my mind. So the planet has the mass of Jupiter, and like I said, it was once a star itself until it lost its outer shell, which basically is a fuel for a star, if I understand that right. And when older stars die out of old age, they lose that outer shell of hydrogen mostly, right? Is that most of the fuel for stars? Hydrogen and helium?
Hydrogen and helium, yeah. Usually one of them, like certain stars will burn helium and other stars will burn hydrogen. One of them is a hotter and brighter star. For the life of me, I can't remember which. That's kind of how the stars go. All their own weight crushes the matter so densely that it causes that nuclear fission, nuclear fusion, and that's where you get all the heat. And when that collapse becomes strong enough, boom, supernova.
And after that point, a number of things can happen depending on the mass of the star. It turn into a black hole. It could turn into a neutron star. It could turn into a pulsar. There's a lot of interesting stages after that. And it all, from what I've learned, and correct me if I'm wrong, it all depends on how much mass is remaining at that point after it goes supernova.
Pretty much, yeah. It if it has too much mass and collapses on itself, it becomes a black hole. If it has enough mass to survive and just kind of stabilize, it can become a white dwarf. If it has a little more mass, becomes even super dense. So you get like a white dwarf that's super dense. It collapses into a neutron star. And then occasionally you get a weird thing where it emits radiation in two directions based on its magnetic pole, and that's where you get a pulsar. I thought pulsars were kind of cool because they're kind of like lighthouses in space.
Yeah, they are. They can rotate really fast or really slow. I think I found one result where there was one that spun 600 times a second. It's just unbelievable. And others have 20 to 40 minute rotations. So it's all just depends on the momentum and whatever was going on before that. So as I dug into this a little deeper, I found that pulsars were discovered by Jocelyn Bell Burnell in 1967. Pretty awesome. What would be the molecular makeup of a planet that was made by a star? I mean, what is the core of a star? It's not metals, right?
No, it's usually just gas, hydrogen,
Huh.
helium, nitrogen, things like that. So
Hmm.
the fact that it could collapse down into an actual rocky planet, that's especially odd because, I mean,
Yeah.
the heavier elements, carbon and things like that, they do come from stars.
Hmm.
Um, the stars produce those elements out in space, so it just have to be a bizarre, extremely rare situation for those elements to just, I don't know, maybe they just collapsed back with the star, or maybe
Hmm.
something happened inside that it caused the production of those heavy elements. There,
Weird.
there is a theory that the center of Jupiter is a giant diamond.
Right. I've heard that. Arthur C. Clarke takes that as well in one of his books. I can't recall.
It was
Isn't
the one after 2001: A Space Odyssey. I think it was like
yeah,
2010
2010.
Odyssey 2. I
Hmm.
remember I read that one, and the one guy is, I think it's like after he loses his body and he's floating through space and he
Yeah,
goes down
he's
into
melded with
Jupiter and
Hal.
goes down into Jupiter and he finds a diamond in the center of the planet.
Mm. Speaking of stars and collapsing, in that book, a little bit of a spoiler, the monoliths, who are kind of against humanity at that point, they actually conglomerate around Jupiter and use their collective mass to collapse Jupiter into a small star.
Oh yeah, they did do that. I totally forgot.
They do that. Yeah, they do that to melt the ice on the moon with the aliens so that they can further evolution on that moon because they kind of give up on Earth.
Mm-hmm.
Kind of spoiled the book, but go read those books. There's four of them. A lot of people don't know that. They are really good.
I did not know that.
Okay, so that's it for my number five. Diamond Planet around a pulsar.
I'm gonna go with my number 5, a super manly one, Stellar Nursery.
Oh,
Nothing's more manly than a nursery, you know.
little baby stars. What the heck is a stellar nursery?
A stellar nursery is essentially a region of space that's just tons of gas, usually like, different molecules of different things. And when it's stable, it just kind of stays as this giant cloud. But
Hmm.
then when something happens, either, it gets enough mass to collapse under its own gravity, or maybe a gravitational wave or something hits it, something triggers a stellar nursery, and suddenly it'll start collapsing down and just spitting out tons of
Ooh,
stars.
cool.
So you'll, in a region of space where nothing's happening, all of a sudden you have like hundreds or thousands of stars just popping into existence and spitting out.
Yeah. Now, when you say all of a sudden, that you're really talking about like hundreds of thousands of years, millions of years. We speculate, right?
Possibly. Although when you, I don't know, time scales in space are kind of really weird because
Yeah.
you have some things that can take billions of years to happen, and then other things that happen in a blink of an
Mm.
eye.
You're talking about gaseous regions in space and births of stars. I've had this question for a long time. I've never really had anyone to ask it to. So, general physics of gas and fluids says that if there's, a fluid, whether it's gas or liquid, in any kind of container, that it spreads out to reach equilibrium. So, how and why does wood gas move towards a center, or how would gravity pull something inwards? Wouldn't it just keep spreading out in space?
Um, well, sort of. The essentially when you have gas, it's a collection of molecules and particles,
Yeah.
and every single particle in the entire universe has a gravitational pull. So
Yeah, technically.
when you have all of those little particles together, they are all gravitationally attracted to each other, and
Hmm.
they'll reach an equilibrium where they'll just kind of stay at a certain distance until something kind of becomes that catalyst and causes it all to collapse and rush into each other,
Hmm.
causing nuclear reactions, building up into these balls of gas. But
Yeah.
um, that so you have the gravitational force of each of those particles all pulling on each other, and that's kind
Hmm.
of what holds the clouds together. Um, Now, to go on a bit of a tangent, if you look at the expansion of the universe, what they're finding is that things are actually spreading apart, and
Mm,
scientists don't really understand why. Because
interesting.
theoretically, everything should be like, you have the Big Bang where everything is thrown outwards, but eventually
Yeah, momentum.
and gravity should eventually be capturing all those things and pulling it back into the center. And into what scientists have theorized call a concept called the Great Crunch.
Yeah.
But
Sounds tasty. Good
yeah,
cereal.
yeah,
They should totally make that.
yeah. The idea would be that everything would eventually collapse back into one point, and then you'd have a second Big Bang, and the whole universe like repeats itself.
Boom.
But instead, what scientists have observed is that instead the expansion of the universe actually is steadily speeding up. And that's one thing that nobody has any idea why. And so, on the one hand, you have these particles that use gravity to hold themselves together. And on the other hand, you have a universe that's steadily expanding and speeding up the expansion for no discernible reason. That's the universe we live in. Makes no sense, but it's tons of fun.
Well, we're talking about gravity, and that goes into my number 4, which is gravity waves. I think the general public just learned about gravity waves a few years ago when they made that huge discovery. And honestly, it had been the first that I had ever heard of it, but they've been around for a few decades. So basically, a gravity wave is a ripple in space-time that's caused by some of the most violent and energetic processes in the universe, such as black holes colliding, which is a crazy thought in itself. Just two black holes, or maybe three, just like consuming each other. Man, I want to see that. Well, you can't really see it, but you know what I'm saying. I wish I could visualize that somehow. And so when that happens, the intense gravity of each body, of say in this case each black hole, they're interrupting each other's gravitational, power, and they cause what ripples in space-time because of the intense gravity. So these gravity waves actually emit from the object in all directions at the speed of light, which is really wild to me. So this is something that's not physically visible. It's not physical in the normal sense that there's, matter moving. But they are, and they're not electromagnetic radiation either. But whatever they are, which is a ripple in space-time, they're moving at the speed of light, outward in all directions. And I'm assuming they kind of weaken, with distance. But we can measure gravitational waves here on Earth with some very precise tools, which was finally done in 2015. In September, they measured the very first official gravity waves. It was from two black holes colliding by something called LIGO, which is Laser Interferometer Gravitational Wave Observatory. So this LIGO is specifically made for observing gravitational waves. And somehow they have an array of lasers with some super precise measurements that basically can tell if gravity waves are messing with a laser beam going, laser beams always go straight, right? So if they bend, that's due to a gravitational wave. If I remember right. Does that ring a bell? Do you know anything about LIGO?
Unfortunately, I haven't heard of that. I have heard of interferometry, which is literally just studying interference patterns and waves and things like that. But you probably get that from the name.
Yeah. So that plays into it. And honestly, I'm a little rusty on my LIGO terminology. I know when it first happened, I read about it. I was like, this is amazing. I actually understand this, Albert Einstein actually predicted the existence of gravitational waves way back in 1916. So just over 100 years ago, this guy is like, hey, these are probably going to be out there somewhere. And like in about 100 years from his 99 years, from his prediction year, we actually observed them. That just blows my mind.
That's wild.
It's interesting how physics works like that. And this is the case for a lot of astronomical discoveries. Someone had predicted them mathematically, or just through, logic and things like that. Based on what they knew about the laws of the universe, they predicted this thing probably exists and this is what it will look like. This is what will happen when it, collapses or explodes. And, 50 to 100 years later, we're observing the exact same things that they predicted. I just love that about science and about astrophysics, because there's just like this kind of Lego block system of rules in physics. Now, they're not perfect. There's still a lot of, wrong predictions, and there's a lot of leeway with certain things. But at the same time, people have called things before they've actually been observed. I just find that really interesting.
Oh, yeah. Kind of makes you wonder what things have been predicted but not found now that will be found in the future.
Yeah, totally. Yeah, some crackpot scientist that's been kicked out of his university. He might be right in 100 years.
Yeah. Like you ever heard of the concept of a white hole?
Yeah.
Basically, it's the opposite of a black hole. It's the idea that since a black hole sucks things in, and you'd never see that matter again. It's theorized that for each black hole, there's a white hole somewhere out there spitting all that matter out, and they're like connected by a wormhole or something like that.
Cool.
but nobody's ever found a white hole. So
Yeah. Hmm. Maybe we have a twin galaxy where the center of that galaxy is a white hole, barfing everything out that gets eaten by ours.
was it Stephen Hawking who theorized that our whole universe might be inside a single black hole? And I'm
No.
like, I
Wow.
think you've lost. I was like, I think you've lost it at this point, sir.
So when I was reading about these gravitational waves, I started to wonder, what would it be like if you were to experience a gravitational wave close up? Like we can feel these, well, we can measure these gravitational waves from literally millions of light years away, which is amazing on its own. But if we can measure the ultra weakness of these waves, what about the planet that is not ultra far away? What if you were in like just a solar system next door to these two black holes smashing together? I mean, Andy, do you know much about gravitational waves? Is that something you studied, or have you read about that?
That's not an area where I focus too much,
Okay.
so I don't really know much about them at all.
Yeah.
So right now, you know more about them than I do.
Yeah. Wow. Hey, that makes me feel good.
But I can anticipate that if you were on a planet near two black holes colliding, you wouldn't be on that planet for very long because the planet
Bye-bye.
would not be there for very long.
No. Yeah. Well, yeah, that's something I definitely want to look up is what is the, close up in person effect of a gravitational wave, say going through your planet? Would it physically just rip the planet apart? Or would it be so subtle that you're slowly rising in relative speed or something like that, and then you're slowly going back to normal and you don't even notice? I don't know. I'm very curious now.
Hmm.
I
That's a
must.
very interesting idea about like the nature of time. How do we know time is not
Yeah.
universally speeding up and slowing down and
Yeah.
speeding up and slowing down on our planet? Like,
Mhm.
I mean, you'd never know.
Now, if in your local area, if everything is rising or falling together, you have no point of origin to go against what you're observing.
So what if our whole planet is like just on one wave that's rising and
Right, right.
slowing? So we're like speeding up, slowing
Or
down,
time
speeding up, slowing
traveling.
down. Yeah.
One of my many stories I have literally written in a list of stories I want to write one day is a planet that is colonized, and they find these strange, like glowing bubbles of different sizes. And when they go inside them, they discover that these are actually time, like relative time bubbles of different speeds. So some are super slow, some are just a little bit slowed down, and some may be sped up, and all the things that unravel with that. So yeah, that's it for my number 4, gravity waves. What do you got for yours?
I have the Great Void.
Ooh, sounds like a nice place.
Yeah. Well, it's not actually a specific. It's more the idea of super voids, which are just large, huge, empty areas of space.
Cool.
So usually you think, oh, there's tons of stuff out in space. There's, all these stars and galaxies. You realize, like, a single star is like, a couple hundred light years from the nearest star. So most
Right.
of space is completely empty. So one of my professors actually explained, like, if two galaxies were colliding, there might not actually be a whole lot happening because
Right.
most of those stars would just be going right past each other because they're so far away.
Hey guys.
And it's kind of like how any solid object is mostly actually empty space
Right.
because
So crazy.
because you have the tiny little subatomic particles that take up just a tiny fraction of an entire atom,
Hmm.
and so most of you is actually just empty space.
Yeah.
And that's the way it is out in outer space, is all these stars that are really far from each other, but we see them we see such large vast areas that it seems like there's a lot of stuff. Well, there's actually these huge regions where there's literally nothing,
Wow.
or next to nothing.
Hmm.
And so scientists at first were like, why are there large empty spaces in space?
It's too much space in space.
Yeah, and it has to do with, from the Big Bang, everything was thrown outwards and things start clumping together. And that's where you
Hmm.
get like galaxies forming. And when things clump together, they leave empty spaces between the
Yeah.
clumps. So one place I was reading was saying, if you imagine outer space like a giant spider web,
Right.
and the galaxies and things are just like the intersections of different strands of web,
Hmm.
and the voids are just the empty spaces between all of them.
Now, isn't there like a dark spot out in space somewhere where they've observed with the Hubble or something like that?
I believe so. That might be I don't know, somewhere near Magellan, maybe.
Like a
Um,
voidy type area. There's not a lot
yeah,
there. Kind
yeah.
of creepy.
There's a number of these. There's
Hmm.
small little voids that are near galaxies, and then there's what are called super voids, which are like just huge, like 100 or 100 billion times the size of like a galaxy.
Wow.
So one thing I was thinking earlier today was like, we don't really realize how big the ocean is until you're out in the middle of it, thousands of miles from anything.
Hmm.
And you just see ocean in every direction. You could row or swim for months and still not reach land. And that's not something you really think about, being on land most of our lives.
Hmm.
But out in space, imagine that like multiplied 1 trillion times.
Whoa.
Like you're in a spaceship out in a void, and there's nothing for like
That's
a
terrifying.
quadrillion miles in any direction.
Yeah, and without assisted optics, you may not be able to see any light at all. It would just
Mm-hmm.
be pitch black to your human eye, and no, maybe not even any radiation, no signals, nothing, no energy.
Yeah.
That's scary. I wonder if absolute 0 Kelvin could be reached there if there's no energy there.
It's just crazy to think of just emptiness
Yeah,
so big that would drive you insane.
yeah. My wife probably would not like to think about that. So the ocean as well as space kind of scare her because of that unknown emptiness. She just does not like that.
Oh yeah. There's
So,
have you seen you've seen Serenity, right?
yes.
Well, I remember at one point, the Reavers, like the
Hmm.
crazy people that
Oh
eat
yeah.
and do horrible things. Um, well, at one point, I think it's Jane, the tough guy. He was talking with somebody else about like, oh, what would make these Reavers go insane? One
Mhm.
theory they had was that the Reavers were people who went to the edge of the universe, saw absolutely nothing, and went completely nuts.
Yeah, I recall that too. The emptiness of space.
Hmm.
And then they'd like to eat people, but they can still fly a spaceship and maintain life support and whatnot, and prepare
Yeah,
meals.
yeah, and somehow worked together on it.
Yeah, together, yeah, to fly ships and coordinate attacks and things like that.
Yeah. Well, I think eventually they figured out it was that weird like chemical put on that
Yeah,
one planet that made them go
the
crazy.
government
So I
cover up.
wonder, yeah, so I wonder if they just weren't interested in each other.
Hmm.
Kind of like how zombies don't attack each other, maybe reavers don't attack each other.
Yeah,
Anyway, went on that tangent.
yeah, that's good. Good tangent. I like it. Okay, so my number 3 is neutron stars. So a neutron star is a collapsed core of a giant star, which before collapse had a total mass of between 10 or 29 times the mass of our sun. So the star was 10 to 29 times larger than our sun. The outer, energy on the shell kind of either was blown away or burned away and just died of old age. But the core that's left of other helium and hydrogen, whatever else is in the core of the star, collapses inwards and makes a very dense thing called a neutron star. It is so dense that the gravity pulls it so tight that the electrons and the protons fuse together and they form neutrons. So literally the atoms, the atomic structure of a neutron star is just neutrons. Isn't that weird? Like how does it stay together? I guess it's just
Yeah.
gravity. It's the immense crazy gravity keeps all those just crowd of neutrons just hanging on to each other. And they are neutral, so there's no force pushing against each other. Like an electron and a proton, they push against each other because of the opposite charges. But I guess neutrons are fine with each other because they're neutral.
Hmm.
But yeah, so that's pretty wild. So if a star has enough mass before it's collapsed, it will actually go even further than a neutron star, and it will turn into a black hole. But a neutron star didn't quite have enough ammunition or fuel for the gravity to do that much damage, but it just collapsed into a neutron star. Neutron stars are generally 9 to 12 miles in diameter. That's really small for anything in space,
Yeah.
honestly. That's like as big as my town. I live in Universal City. It's kind of a small edge of San Antonio area. And I mean, I haven't measured on Google Maps, but I'd assume it is probably 5 to 15 miles in size. And there's a star out there. There's billions of stars the size of my town that are way more massive than my sun.
Yeah, that's
Blows my
that's just
mind.
mind-boggling right there.
Hmm. So a teaspoon, if you were to somehow, go out, bring a teaspoon measurement to a neutron star, just casually scoop out a little teaspoon of neutrons, it is so dense that it would weigh 10 million tons. A teaspoon. Now, just like you said, there's so much empty space, not only inside of the atom, but also in between other atoms. I guess depending on what the heaviness of that molecule is. But inside and around atoms is a lot of empty space. However, with the gravity so intense, I'm assuming there's not a lot of room between these neutrons when they're packed together. So
Yeah.
that means it could easily be, thousands to million times more dense than what we would normally consider a heavy element. And that's how there's so much mass and so much weight, which in space, that means high gravity as well. And it just all just keeps it together.
And if I'm not mistaken, a pulsar isn't that a kind of neutron star?
It is, yeah. So if there is a star orbiting a neutron star and the gravity of the neutron star begins to eat away at that orbiting star, then the stuff that comes off of the orbiting star and comes into the neutron star will cause radiation to shoot out. Because remember, that gravity of the neutron star is so strong, it just tears apart whatever is coming into it from the surrounding star, and it begins to shoot out. It ejects some energy in the form of X-ray and radio waves out of the polar coordinates of the star. So yeah, I think it requires another star to be eaten in order to shoot out energy and become a pulsar. Pretty cool. And one more thing about neutron stars I learned is that the gravity is so strong that gravitational lensing occurs, which is when gravity is so strong around usually a black hole, but also apparently neutron stars can do this too. The gravity is so strong that light from behind the star gets warped around the body of the star, and we see a warped, bent version of the stars behind the neutron star we're observing, or the black hole.
And so that's where it gives you the impression of being two stars when it's really one star, right?
Yeah, it can do that. Yeah. There's even gravitational lensing with galaxies. So we've observed a galaxy behind a galaxy, and I think we've observed a triple. I think we've observed something being bent around an object, which was being bent around another object, and they were either black holes or galaxies. And again, this is something that I think Albert Einstein predicted, gravitational lensing, and we finally observed it. That should have been on my list. Gravitational lensing. It's just, I'm a photographer, so I love light. I love like refraction. I love optics. And this just blows my mind because there's no glass involved. It's just crazy gravity bending photons around and literally distorting what we see out in space.
I was about to say, you're the photographer. You should be all over anything with photons.
I know. Oops.
I still have a picture you took of me and my wife as my profile picture on Facebook.
I noticed that, and that warms my heart every time I see that. How long has it been?
That's probably like 5 years ago.
It's a good photo, though.
Because I think we did that photo shoot where we were the time travelers.
Ironic.
And then I think later on we did the Harry Potter photo shoot where we're witches and wizards.
That was great. Yeah, it's funny we're talking about all this sci-fi space-timey stuff, and your photo is of you being a time traveler.
Oh, yeah.
So that's it for neutron stars. Pretty wild. Don't go too close to one.
Yeah. So my next one is the cosmic microwave background radiation, also known as CMBR, or CUMBR.
Cucumber.
So the cosmic microwave background radiation is kind of one of the oldest things in the entire universe, and it is a remnant of the Big Bang. So essentially it's like all radiation is literally just energy leaving an object, So you have, visible light, you have heat, X-rays, ultraviolet light. Well, this CMBR is literally microwave radiation that's just left over from the initial explosion of the universe, and it's steadily been dissipating, but 13.6 billion years it's still there. So it's not very fast, but it's one of the furthest things we can see, and yet they found that it can be detected between areas in places where we think there's nothing, where it's just blackness. There's still faint traces of it.
Yeah, a little bit of that hanging around.
Yeah, and there might even be some of that in like the great voids. It's just that, it might be the only thing in a great void. So, but it kind of reminds me of, have you ever read C.S. Lewis's Space Trilogy?
I I think I
Or
finished the first one. I couldn't finish the rest.
I was going to say his first one is the only one I read, the Out of the
Yeah,
Silent Planet.
yeah,
It's interesting, but one of this CMBR kind of brings to mind the when the main character, whatever his name is, when he leaves the atmosphere of Earth and he sees all these things just floating in space, like sort of angelic beings,
hmm
and he realizes that what he thought was empty space was just brimming with all of these things. Um, but humans hadn't been able to detect them because Earth was under quarantine, basically. And
yeah,
so this kind of reminds me of that. Like, there's this stuff that's just floating out there that we don't think is out there. We think it's just empty space, and yet there's this stuff floating in it. Um, it's kind of like the concept of the ether, like the idea
yeah,
that
yeah.
there's just this substance out there, and ether doesn't really exist, but the CMBR does. So it's
Hmm.
just kind of like fragments of a shell that's just out
Wow.
there slowly dissipating
That
at the
brings to
furthest reaches of
mind,
the universe.
and we're talking about C.S. Lewis and background radiation from all over the universe. That makes me think of Psalm 19, where it says, Psalm 19:1, it says, the heavens declare the glory of God, the skies proclaim the work of his hands. Now, if you take that uber literally, you're literally saying
Cumber.
that space is proclaiming and singing and making noise about God's work.
Yeah.
That's one
I mean, if you
interpretation.
think of sound as just the motion of particles and waves and stuff out there, then
Mhm.
there is lots of music out there. Well, don't misinterpret what I'm saying. I'm not saying you can hear things in space, but metaphorically.
Yeah. There's plenty of sounds you can hear, not audibly with our human ear, but there's sounds like pulsar sounds. They've actually um, moved them down into the audible range of hearing and kind of playing with the pitch to where you can hear certain things in space. And it is really eerie. I do encourage you, if you're interested in sound and space, look up the sounds of space. You can hear pulsars, you can hear stars, planets emitting all kinds of frequencies. It's really interesting and eerie. Uh,
It's kind of like the concept of the music of the spheres.
Yes, yeah, it is. There's one sound out in space. I forgot what it was. I think it may be have to do with radiation, but it sounds like dolphins, kind of like a high pitch, like a dropping pitch sound. It is really cool and creepy. Moving
I was
on.
going to say, that sounds so vaguely familiar. It'll probably come to me in like 3 days.
So my number two is the Rogue Planet. This sounds like a name for like a 50s sci-fi, but it's not.
Mm-hmm.
Um, so again, I'm going to list a scientific nomenclature for this rogue planet that we have observed flying through space, all on its lonesome. It is CFBD SIR 2149. Again, a great planet name. I mean, that's a place you want to call home, right?
I think I might
CFBD
name my next
SIR.
kid after that.
Come here, CFBD SIR 2149. Get over here. Okay, so this planet is a free floating planetary mass, that's what it's called scientifically, and it is floating through space in the Aquarius constellation. There's no stars orbiting. I don't know if there's a moon, if we can even observe that close yet, but it's just zooming through space. The spectroscopy observations have found that light absorption that there is light absorption by a gaseous methane and water mixture in the atmosphere. So this planet has some amount of atmosphere, which is interesting because if it's not orbiting around a sun, it's probably really cold,
Yeah.
and that will eventually take a toll on the atmosphere, I'm sure. I mean, I don't know. Maybe you can keep your atmosphere better if you don't have a star, because the radiation and heat from our sun does constantly bombard our ozone and things like that.
Yeah.
I don't know. I'm no expert. It'd be crazy to live on a planet like that. If you had some kind of internal heat source, like a really hot core with lava and stuff, you might be able to survive with heat, um,
Mm-hmm.
and live on a free floating planet. Which I would love to write a story about that one day. That'd be really cool.
Yeah.
There actually is a book that I read, and it's one of my favorites. It's called Pushing Ice, and I believe it's by Alistair Reynolds. Either him or Stephen Baxter. I think it's Alistair Reynolds. It's called Pushing Ice, and there is one of the moons of Jupiter begins to accelerate in a straight trajectory, and then it turns directions and blasts off somewhere else. So there's a nearby mining group, and the corporate. It's like, hey, we need you to go get this thing. Go check it out. What's happening with this moon? It's flying away.
Was
And
it named Janus?
I
The name of the
think
moon?
I don't remember it. That might have
I
been
might
it.
have I might have read this, and it turns out like if I'm remembering this correctly, is it okay if I do a spoiler?
You go ahead.
So it turns out the moon was not an actual moon. It was created by aliens
Yeah.
to like collect some random species and bring it back to its what was it called? Like a
Trading
Dyson, not a
post.
Dyson trading post. Like basically just somewhere where it would keep those like a giant zoo.
Yes. Yeah. Well,
Ah,
it's like a merchant meetup. For each major solar system, there's one, and you can trade stuff. You can drop stuff off and trade it, and learn about other civilizations that have gone there in the past. And
there were like the fountain heads, which were friendly, and
yes,
the musk dogs, which were super creepy and
yes,
just
dude,
messed up.
that book is awesome. It's like a good standalone book.
That book is 10 kinds of crazy, and I
Yeah,
loved it.
yeah. Alistair Reynolds is my favorite.
Yeah, I remember it was crazy because like they're blasting off into space and they live for like decades and decades and bring up a new generation and they colonize this
Hmm.
planet or this moon and then they receive this random object which unlocks and it's from future Earth. So
Oh,
somehow
that's
like
right. Yeah,
they had beamed back enough information to Earth to where it like jump started Earth's technology and they got super
yeah.
advanced. But since this moon was going through space so quickly, they experienced time dilation.
Hmm.
So it was like hundreds of years on Earth, but only like a couple decades for them.
Yeah. So Earth got
And
there first.
Earth was able to actually send them like a thank you gift, which was,
So
hey, here's this message from us
hmm we're doing great.
from your future.
Thanks for curing cancer, by the way.
Yeah.
Yeah, I forgot about that detail. That is so cool. Well, sorry if we spoiled the book for you, but we didn't really. You should just go read it. Go listen to it. I
Oh,
got it for free. I
there's
got
so much we didn't mention in that
Yeah,
book.
yeah, yeah, totally. I got it for free from my library, and no regrets. All right, so back to the Rogue Planet. I learned about something called the ABDMG. It stands for the AB Doradus Moving Group. So the ABDMG is a group of about 30 stellar objects that are kind of drifting on their own together. Now, they're not close together by any means, but they're just spread out, but they're all moving roughly in the same direction. They're kind of on their own. So this object is one of them. So we don't know how that happened exactly, but they're just kind of going this way. Everything else is going that way. So what are your thoughts on how a planet could become a rogue planet? How could that even happen?
I mean, it could be maybe it was once orbiting a star and the star went supernova,
Hmm.
but the planet was far enough away to where
Didn't get fried.
instead of getting roasted, it just
Yeah.
got blasted away
Oh,
and
lucky
suddenly it's
them.
just wandering through space.
Yeah.
Maybe it was orbiting a much larger planet, like a Jupiter-sized planet,
Hmm.
and then something happened to that planet.
Yeah.
Maybe it
Got
collapsed.
ejected.
Maybe it broke. Yeah, I think there was a book I read once about where scientists found like human-like alien skeletons on the moon, and they eventually found out that the moon was originally a moon of Jupiter,
Oh, dang.
but but which was colonized, but something or no, the moon was originally orbiting this big planet the size of Jupiter,
Uh-huh.
but there was some war between different species and they blew up the planet and that ejected the
Whee!
moon
Yeah.
until it got caught by the earth.
Oh,
And
good catch.
these skeletons that were on the moon were just people who happened to be on that moon when their planet exploded and they found themselves just shooting through space.
A lot of archaeology going on in that that story.
Oh yeah, there wasn't much actual story in the story. It
Just
was
that idea.
mostly like we found a skeleton, and the whole book was just these scientists
Exposition
learning.
everywhere.
Yeah, just learning.
Oh yeah, that only goes so far into sci-fi. That's definitely a trope. Is the exposition scenes where the scientist gets to explain wormholes again to everyone in the audience, and we already know the basics.
Oh yeah.
Even Interstellar, they had to do it.
I know you love Interstellar, but they
I do.
totally stole their explanation from Event Horizon. I'll just say that.
Oh really? Remind me,
Yeah.
what do they take?
Well, remember in Interstellar when they explain it, they're like, "Oh, imagine this paper were on these two separate points, but
Yeah.
instead of flying directly between the points, you just fold the paper in half and punch a hole, and he uses a pencil to punch through the paper."
Oh, but that trope's been
And
on
says,
forever.
well, the first time I ever saw it was when
Was it?
Sam Neill was doing that exact same thing in Event Horizon,
Okay.
like almost word for word.
Yeah, that paper example. I just feel like I can't even count how many movies I feel like it's been in. But now I'm curious. I wonder if there's an earlier example, or if you are in fact right, and that is the first cinematic paper example of a wormhole. Could be.
I don't know.
I think we've done some episodes about sci-fi movie tropes and cliches, and it was super fun because as much as I absolutely love sci-fi, I also absolutely love to roast it.
Yeah.
Because I grew up watching Mystery Science Theater 3000, and I know how to make fun of stuff.
Oh yeah.
It brings me almost as much joy as watching it does.
That's the joy of the Sharknado movies.
Yeah,
you don't
exactly.
watch them for good cinema. You watch them to laugh hilariously.
And roll your eyes. Wonder how did this get made?
Although my buddies and I, we did figure out the formula for the Sharknado movies, just in case you're curious.
Oh, yeah?
The formula is a very simple formula. Whatever is most absurd and crazy, ridiculous, but awesome, they will do. And they will work the story around it.
Yeah, make it work.
That's how you get, like, one of the movies opened with a guy with the main character like sliding on his knees through the White House, flags flying in the air, shooting two machine guns at all the sharks that are flying around.
Oh, Lord.
It was literally the most American movie scene I've ever seen.
We're going to do an episode on that. I have a thing in the works called cringe reviews. And we're going to do movie reviews of terrible movies that everyone knows is bad, but we're going to talk about why and how it actually got made. So I'm adding that to the list. I think it already is on the list, actually. All right, so let's get back on topic. Andy, what's your next weird thing out in space? What do you got on your list?
Dark matter.
Ooh, good show.
And I'm not talking about Buzz Lightyear's evil archenemy Warp Dark Matter from the Buzz Lightyear TV show that I did in fact watch. I have no shame in that.
No shame.
Dark matter, we have no idea what it is. We can't even observe it. It's entirely theoretical.
Oh, fun.
But they think it makes up 85% of the universe. So what they did, scientists have looked at like the rotational velocity of galaxies, as well as, you know, the kind of the ways galaxies interact with each other. And through observation, scientists can figure out how much mass is in a galaxy. Well, mass is related to the rotational velocity because of momentum and everything.
Yeah.
And looking at the rotation velocities of galaxies, they figured that the mass that they've calculated being in the galaxy only accounts for like 15% of the matter needed to hit that rotational velocity.
Wow.
So they're like, well, what the heck is the other 85% of the mass that's there causing this to move so quick?
Mystery.
Yeah, it's kind of like if you imagine a grasshopper somehow getting a merry-go-round going. You're like, clearly the grasshopper is not the only one building up some momentum there. Since we can't observe it, it's whatever this matter is, it's invisible. We're not getting any traces of it. That's why they call it dark. It's not like it's black. It's just invisible.
Mm-hmm. Well, hopefully one day we'll be able to observe it, capture it, analyze it, something.
Yeah, I remember in if you've ever watched Futurama, the Niblonians. The Nibbler and his people, they poop out dark matter, which is what fuels all the spaceships.
Nice.
And I just remember an episode where Fry is taking Nibbler on a walk, and Nibbler poops on the sidewalk, and Fry gets out a little napkin. He's trying to scoop it up, but he can't pick it up. And a police officer comes up and he goes, "Hey, you got to clean that up." And he goes, "I'm trying, but it weighs the mass of 10,000 suns." And it's just this little thing like the size of his palm.
The neutron poop. That's funny. If dark matter exists in the way we think it does it consist of particles? Is it something extra dimensional or energy rather than matter?
They do have a concept of dark energy, but I don't really know what that is. It's hard enough for me to even comprehend dark matter, so I'm like,
yeah,
okay, reach my limit here.
I'm gonna head out. Um, all right, so my last thing on my list, my number one weird thing we've discovered in space is, of course, black holes. I know, kind of saw it coming, but regardless of how popular they are in sci-fi, they are still just the craziest things to me that constantly blow my mind. So I'm just going to read the Wikipedia description of a black hole because I feel like it really summarizes it very well. So let me just read from Wiki. A black hole is a region of space-time exhibiting gravitational acceleration so strong that nothing, no particles, or even electromagnetic radiation, such as light, can escape from it. The theory of general relativity predicts that a sufficiently compact mass can deform space-time to form a black hole. The boundary of the region from which no escape is possible is called the event horizon. So,
Dun dun dun.
and roll the movie. That movie is terrifying, by the way. It totally messed with me when I was younger. I should not have
Oh,
watched
it
that.
is. I love that movie, and I don't want to watch it anytime soon because it is absolutely terrifying.
Yeah, I was doing a little homework on it a long time ago, just out of curiosity, and I came across on YouTube a video compilation of all the hell scenes, and they are
Oh my
messed
gosh.
up.
I will say in that movie, I'm very glad that they show it as really fast cuts
Yes.
so that you get the impression. Because
Yes,
I'm
yes.
like, oh my gosh, if they hovered on even one of those images, you would want to rip your own eyes out, like Sam Neill does,
Like he does.
when he sees it all.
Naturally.
He straight up rips his own eyes out.
It's things like that, and other shows that are, I mean, mostly horror and gore fest movies, or sometimes worse. It just makes me wonder, these writers and or designers, they need a psychological evaluation. Like they need to be watched by the NSA because something might be wrong with them. Just putting it out there.
Yeah. Well, there's I'm a horror fan, so I know there's like different kinds of horror, just like there's different kinds of nerddom. And so I'm more a fan of like the creature feature, in case you haven't figured that out, or like cosmic horror, stuff like that. But there's like the torture porn and the gore.
Yeah.
Oh my gosh. I absolutely detest those.
Like Saw.
I'm like, I enjoyed the first two Saw movies because they focused more on the psychology than they did the gore.
Right.
But then when you get to Saw 3, I'm like, this is too much.
It's terrible.
They skewed in the wrong way.
Yeah. They're just trying to make some more money.
I would have paid them not to make Hostel.
Well, Hostel was bad too? I didn't see that.
That is the definitive torture porn.
Yeah. It'd be hilarious if someone started a GoFundMe to raise money to not make a sequel of something. That'd be so funny. Pay them off to stop. That'd be hilarious. So, Event Horizon. That was a good tangent.
Yeah, so Event Horizon. So I was thinking, like, just a random thought experiment. You know, how would you go about colonizing distant planets? You could go sleeper ship, where you're cryogenically frozen and you wake up like 1,000 years later. Yep. There's generation ship, where, you know, you just have a living ecosystem and it's your great-great-grandkids that are going to colonize the planet.
Right.
Or you have wormholes.
Me likey.
And in my mind, that's the most realistic way of colonizing the galaxy, because if you use wormholes, you can still stay in contact with the original Earth and stay on the same time as them.
Yeah, and not have to travel super far.
Oh, yeah. The downside to this is you might accidentally open a doorway to hell, get lost for 20 years, and come back with your ship all possessed, killing people.
Don't you hate when that happens?
So that nixes that idea.
What a downer.
That also completely explains Event Horizon for those of you who haven't seen the movie.
Yeah. Were you a Battlestar Galactica fan? Did you watch the remake?
I did not.
Oh, it is my number one, which means you need to watch it. But tiny spoiler, but not so much if you haven't seen it. The Cylons, which is the bad guy robots, they are discovered to have a home base somewhere way out in deep space, and it is based around or orbiting around a black hole at a safe distance, which, I don't know if there is one, but and they like to live on the edge, you know, literally the edge of Event Horizon. So the Event Horizon, that term refers to basically the point of no return. So once you get within this radii or this circumference of the Event Horizon, you're done for. You cannot escape the pull. Even if you travel the speed of light, which in every other case would get you out of any, you know, gravitational pull of any body, astronomical body. But the black hole, it sucks in even light, so you cannot escape no matter how fast you go.
Technically, we can't even see black holes.
Right.
We just see the not anything
The
that is
nothing.
the black hole.
Yeah, we see the nothingness, which is why they call it the hole of blackness. It's a black hole. So they used to call them frozen stars as well.
Really?
Because they're not emitting light. They're, everything goes in and nothing comes out. But one way to see a black hole is, like I said earlier, the gravitational lensing that occurs around the edges. So the stars that are behind, we can see them around the edges now because they're being bent and warped around the black hole. And we covered this in a previous episode, how things were done in sci-fi movies, like special effects and things like that. And I, of course, had to cover the black hole simulations in Interstellar because they're just amazing. And what they did was they came up with an astronomically accurate mathematical model of a black hole and what it does to light around it so that they could somehow figure out, hey, what does a black hole really look like if we were to get close enough to visualize it? And so the black holes that you see with computer graphics in Interstellar are as accurate as we can get right now. Not only did it give us a great visual, but they have used what they discovered for the simulation of the movie. They used that to actually discover further astronomical discoveries outside the movie. So that model they made was used for legit discoveries after the movie. And that's
cool.
Yeah, like the director or the co-director, one of the guys on the crew of the movie was actually an astrophysicist as well. Like, how convenient, right? So he helped, and some other really super smart people like put together this model. Turned out to be like super accurate, and they learned things about it. They learned that a photon of light coming from behind a black hole can rotate around 13 times before exiting and coming towards us. So
cool.
Light will just go wee, 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 and then maybe shoot out somewhere if it doesn't get sucked in. Cool stuff. So go back and find that episode. I wish I knew the name of it. Foot and mouth. But light does weird things when there's intense gravity involved.
Yeah, they have found right when an object is about to pass over the event horizon, there will be photons that like blast off in the opposite direction.
Ooh.
And that's called, they call that Hawking radiation.
Oh, that's what that is. I have that as a question here. What is Hawking's radiation? Because I came across it. And I'm thinking, how does this escape a black hole? But cool.
Yeah, basically, as something is crossing the event horizon, certain photons will just shoot off in the opposite direction.
Very cool.
What I think is creepy, when you imagine what it would be like if you as a person, or if you were an astronaut and you were getting sucked into a black hole.
Oh, no.
So it's not very pleasant. Essentially, the hardest thing is the idea of what's called spaghettification.
Yummy.
You might guess from the word spaghetti what that's like. Essentially, the pull of gravity changes so rapidly that, say your feet are facing the core of the black hole and your head's facing away, you might get 1 G of gravity pulling on your head, 10 G's pulling on your waist, and 100 G's pulling on your feet. And so you would literally get stretched out into this elongated thing. And that would probably be pretty agonizing for the quarter of a second that you're still alive.
Yeah, till your brain gets ripped to pieces and you're dead.
Yeah. But on the flip side, if you were getting absorbed by or sucked into a black hole, time would also slow down so much that if you looked outside the black hole, you would see the whole universe aging extremely rapidly. You might see a billion years pass.
What?
While if someone is watching you get absorbed, they might see you just kind of almost freeze right at the event horizon.
Gosh, I want to write a character now that's like this scientist has just lost all hope and he wants to see the universe die, and so he wants to drop into a black hole just to observe it and go out with a bang. That's crazy. Yeah, that's interesting because
you better go feet first.
If for you it's slowing down while you approach the singularity, which is the center of it, then the outside is doing the opposite. Outside is speeding up relative to you. Wow, that's cool.
So you might be able to see the whole life cycle of a star.
Yeah.
Whereas a whole civilization might see this astronaut just perpetually floating right outside a black hole.
Never quite disappear. That'd be weird.
Yeah.
So there is a radio source known as Sagittarius A, and that is coming from the core of our Milky Way galaxy, and that is the black hole in the center of our galaxy. There's a supermassive black hole, which is just like ginormous. I found a scale on it. Now, this is according to Wikipedia, which there's different numbers out there, but this one says that a supermassive black hole, I think is the diameter from either side, could be 400 AU. Now, the 1 AU is the distance between the sun and the Earth, which is like 93 million miles. So 400 of that, that's how big a supermassive black hole is. 400 times the distance between the Earth and the sun. That's like bigger than our solar system, I think. And that's wild to me. There's actually 4 different classes of black holes, and they range in size. So there's a supermassive black hole, which is 400-ish, maybe 100-ish AU in size. Then there's the intermediate mass black hole, which can be about the size of the Earth up to a few hundred times the size of the Earth. Then there's a stellar black hole, which is roughly 300 kilometers across, and a micro black hole, which is 0.1 millimeter. Now, this is weird because I saw another website that said it could be like 15 kilometers across. But Wikipedia is telling me 0.1 millimeter. I don't know. A little difference in numbers.
Tiny.
There. But it's micro, okay?
Little baby black hole. You get your finger stuck in it,
Goodbye, finger. I mean, even in space terms, 15 kilometers is super micro. Yet it has the mass of the sun or greater. The fact that the mass and possibly even the gravity of the sun could fit in the size of my small town is just terrifying. Like, wow.
Mm-hmm. Well, I remember, weren't people terrified when the Hadron Collider came online that it was going to create a black hole and suck up the Earth?
Yeah. Oh man, so many conspiracy theories and wacko things came out of the Hadron Collider, man. Everything from Satanism to portals to, the afterlife to that black holes, destruction of the entire universe. You name it. The Hadron Collider can do it.
Oh yeah.
I was wondering this, what would it be like if you had a micro black hole in your possession? On Wikipedia had different numbers. It said a micro black hole could be a 0.1 millimeters and have the mass of the moon. So I was thinking, what if you had a piece of sand in your pocket or in your possession that had the gravity of the moon sucking inwards on it? Like,
you probably wouldn't be able to wear those pants
or anything. I don't know. Would it stick to you? Would you like wrap around this piece of sand? I don't.
My guess would be it would probably fall to the earth, and you probably wouldn't be able to pick it up because not saying that you're weak, but you're probably not strong enough to lift a moon.
No, probably not.
Not unless you're Thanos,
Superman could.
Oh, Superman can do anything. He can even turn back time by not following the laws of physics. So yeah, I would say it would probably fall to the earth. You probably wouldn't be able to pick it up. And if you went close enough, you'd probably get stuck to it and maybe even sucked in, is my guess.
Crunch. There is a sci-fi movie. I was racking my brain to try to remember the name of it. It came out in like the mid-90s. It wasn't Contact, but it was kind of in that era because I watched it a lot growing up. We had it on VHS. And basically this guy finds an alien base on like in Mexico, and they're terraforming the Earth. So global warming is actually terraforming via these aliens who have secretly made bases around the Earth. He comes upon one that's like stealth or whatever, and the aliens are disguised as humans. And one of the cool things in this movie that is still cool to me, it aged very well, is the aliens have a weapon. It's a miniature black hole device. So that it's like this etched golden globe that they put inside a room. It's about the size of like it's smaller than a soccer ball. It turns on remotely and it levitates in the middle of a room, starts spinning around, and it sucks in everything for like 10 minutes and then just turns off. And it is, I always thought that was so cool.
I would love to see that movie.
Yeah, I gotta find the name because it probably hasn't aged too well, but it's worth a watch. It's 90s had a lot of good sci-fis. It really did.
Oh yeah,
they were really pumping them out. And that was one of my childhood favorites. That and Contact and Lost in Space. Loved them. So cool.
Oh, the one with Gary Oldman and William Hurt and
have you seen
Matt
it recently?
LeBlanc. I saw the TV show on Netflix, but
that's a good show.
That is, I watched both seasons and it's awesome. But I love that movie. It's ridiculous and crazy and so much fun.
Well, rewatch it and then listen to our episode about it because we did a movie review on it and it was a good one.
Oh yeah.
We also talk about some cool behind the scenes stuff about how it was made, which I love. So
I just loved the Gary Oldman spider person.
Duh.
It's such an awesome monster.
Yeah, it was pretty terrifying. one other really cool thing I found about black holes was that there's two different types of black holes, and that one is spinning and one is non-spinning. Now I don't know if this is theoretical, or it may be just a theoretical distinction. We don't know if it's really spinning or not, but they theorize that if there is a spinning black hole, you could possibly escape the event horizon. If it's non-spinning, there's no hope, they say. But if it is spinning, you could actually escape through some crazy means, probably intense acceleration and getting the right vector and whatnot. You can, orbit your way out of there. I don't know. But they said that if you do exit a spinning black hole, you might come out in a different time or possibly a different universe. And I just thought that was really compelling. Like, what if you took this crazy 1 in a quadrillion Google chance that you went into a black hole and came out somewhere, some other time?
Came out in a universe where the Avengers were real.
Sweet. I'm in the right universe.
Is it okay if I share something that I thought was kind of cool?
Yeah, go ahead.
It was shared with me by my buddy Jason. I think you know my buddy Jason. So he got it from, I think this is Reddit or something.
Oh boy.
He compared the sun with a Lovecraftian monster. So he said, the sun is probably the closest thing we'll ever have to a true eldritch abomination. Hear me out here. It's older than recorded history, was here longer than any of us, and will be here long after we leave. It has a finite beginning and end, but is still incomprehensibly ancient. It burns itself into your vision instantly and can blind you if you look for too long.
Nice.
Further prolonged exposure can cause cancerous growths. It's a non-humanoid shape floating through space, and it occasionally has colossal flaming tentacles that angrily lash out on occasion. Sort of just appeared one day, and I'm not going to read the rest of that one because that's dark. People used to sacrifice other people to appease it, and the last one, pretty sure it screams at us sometimes. So he was saying the sun is the perfect example of a Lovecraftian monster.
Yeah, that's something that's funny. Something similar to that got me a good laugh was from, I think it was Stuff You Should Know podcast, which is one of my favorites. And they were talking about sunblock. And they basically said that the sun is continually trying to kill us. It really is. If it weren't for our ozone, we would be so dead. Like, it is a source of so many ailments and problems that we encounter. And thank God for our ozone that does so much, protection of us. But still, the sun is trying to kill us.
There was an episode of The Outer Limits, I think, where the people where the Earth was suddenly getting this signal from an alien planet, and anybody who listened to it, if they were below a certain age, it caused them to start to mutate, and the mutation would be their skin becomes chrome.
Oh, cool!
Like, gets all reflective and stuff. Their hair falls out, and their vision changes. And so at first people thought, oh man, it's this alien species is trying to invade us by turning our kids into them. And then near the end of the episode, they finally figured out that the sun, I think it was the sun, was about to undergo some sort of transformation, or else the Earth was going to go through some transformation. And this mutation allowed people to survive without any sort of issues. And so this signal was sent by a species trying to save humans.
Man, The Outer Limits does it again. So good.
Yeah, and so it ended with like everyone below the age of 30 or 40 or something like that would turn into these like bald chrome-looking humans, but everyone else would have to just stay inside for the rest of their lives.
That's great, man. I never knew about that. I love Outer Limits. Such creative ideas.
Oh, so bizarre, so crazy.
Mm-hmm. Awesome. Well, that wraps up this episode. Thank you so much for listening. I hope you enjoyed it and learned a few tidbits about astrophysics and astronomy. I know I sure did. And Andy, thank you so much for giving us some of your time and coming on the show.
It was a blast. It was my pleasure.
Yeah, I know this is definitely going to be one of my favorite topics discussed on the show. So I'm looking forward to having you back on the show sometime in the future. Maybe we can do a book review or talk about writing or fantasy, sci-fi, something. We got a lot of things in common.
If you ever do anything on H.P. Lovecraft and cosmic horror and space monsters.
That's your thing.
I am your man.
All right, I'll keep you in mind for those categories. All right, well, thanks again for listening, guys out there. We'd love to hear back from you. We'd love to get feedback from our listeners, so you can send us an email or you can message us on any of our social media accounts. Our email is tvvpodcast@gmail.com. That stands for The Visionary Variety Podcast. So tvvp@gmail.com, or you can message us on Instagram or Facebook. We'd like to hear back what you thought about this episode. Let us know what your favorite weird things are out in space, or any article or discovery you've come across, maybe some speculation about something they found. Or if you just have a suggestion for a future topic, we're all for that too. So write us, talk to us. We want to hear back from you. All right. Well, thanks for listening to this episode. We'll see you next week.